I want you to think back to your last major move. Really try to picture it.
Oh.
Right. And I don't mean the fun part where you're happily arranging throw pillows in the new living room. I mean the absolute thick of it, the panic.
Oh, yeah. The stress is just next level.
It really is. Were you stressed? Did you have that, like, visceral moment of looking at a massive mountain of cardboard boxes and wondering if you've made a terrible, life-altering mistake?
I think everyone has that exact moment.
Yeah, exactly. And we are looking at a presentation today that captures this psychological friction perfectly. It's from a Zillow AI Investor Summit, delivered by a product manager named Nicholas Stevens.
Right. And he opens his presentation with this incredibly relatable story.
Yes, he talks about moving with 2 kids and a cat, which, by the way, he highly recommends against doing.
Naturally.
And he talks about, surviving on just 4 spoons because literally everything else is packed away.
Yeah.
And he's just trying to finally get the Wi-Fi working.
It's those little things that break you.
Exactly.
Yeah.
And he realized something profound in that moment. When you are the one actually moving, real estate questions are no longer just like academic.
Yeah.
They are intensely, overwhelmingly personal.
They really are. I mean, it is the ultimate high-stakes decision, right? And analyzing this presentation gives us this amazing lens into the intersection of that high-stakes emotional journey and artificial intelligence.
Totally.
The overarching mission of this deep dive into the summit material is to understand exactly how AI is transforming what is arguably the single biggest, most stressful purchase of your life.
Okay, so the first question that pops up when you hear, AI in real estate
Yeah.
is one I had immediately.
Which is?
Why can't we just use the generic AI tools we already have? The standard conversational models everyone is already using on their phones every single day.
Right.
Like, why rebuild the architecture from scratch?
Well, that gets to the core limitation of generic large language models, or LLMs, when they're deployed in highly specific, high-risk domains.
Right.
Generic models are fantastic at surface-level aggregation. Like if you go to a standard AI right now and type, find me a 3-bedroom house in Phoenix under $450,000.
Well, just do it. Right.
Yeah, exactly. It will crawl the web, find real listings, and summarize them. It performs a basic search function really well, but the moment you require relational context, the whole architecture breaks down.
Okay, let's unpack this, because Stevens uses a really great example in the presentation to show this. He talks about a user asking a generic model, does this specific house have a fenced yard so my 5- and 7-year-olds don't run out into the street?
Yes, which is the exact point of failure for a generic model.
The AI completely freezes.
It totally loses the conversational thread. It asks which house you mean, and then it just defaults back to a generic web search.
Because it doesn't actually know what you're looking at.
Right. It lacks a domain-specific retrieval-augmented generation pipeline, what we in the industry call RAG.
RAG, yeah.
Yeah, so without a vectorized database of property-specific attributes that are actively mapped to natural language queries, it can't be an actual partner in the process. In real estate, that technical failure creates what the source material calls a trust-busting moment.
A trust-busting moment.
Yeah.
Because the stakes are physical, not just digital. I mean, if the AI hallucinates a fenced yard just to satisfy your prompt, and you buy the house based on that data...
Your kids are playing in traffic.
Exactly. The margin for error is 0. So to understand how a specialized architecture solves this massive context problem, we shouldn't just walk chronologically through the presentation's features. We really need to look at how real people interact with these systems conceptually.
I agree. The use cases are where this gets fascinating.
Right. So we're going to look at 3 users who were given access to Zillow's new AI mode on its very first day. And the first user, Beth, demonstrates the concept of platform breadth and integration.
Right. So Beth is a first-time buyer looking in Phoenix. She's been renting, she's used some of the platform's other tools in the past, and she's trying to figure out if it's finally time to pull the trigger and buy.
A big moment.
Huge. And her initial interaction is just a textbook example of user skepticism. She finds a home she kind of likes and asks the AI, does this home have any recent renovations or upgrades?
She's testing it.
Totally. And the AI instantly replies with highly specific details. It tells her about an updated kitchen, a finished basement, a slate roof, a Lennox HVAC system, and even notes it was built in 1938 with a brick exterior.
Okay, let's unpack this. It's like she's going on a blind date with the algorithm.
That's a great way to put it.
Right. She's sitting across the table asking a few surface-level questions to see if the AI is actually retrieving specific property data or if it's just, generating generic real estate fluff.
She's stress testing its context window.
Exactly. But once the AI proves it actually has the hardware specs, she crosses a threshold. She asks the integrated question. She types, "Can I afford to buy this home right now?"
And this is where we see the transition from a passive language model to an active orchestration layer.
What does that mean in practice?
Well, if you ask a generic AI if you can afford a house, it gives you a math formula.
Like a textbook answer.
Exactly. It tells you to calculate your debt-to-income ratio and leaves you to figure it out. But the AI in this presentation utilizes API tool calling. Zillow has an existing product called Buyability, which already has about 4 million users.
Oh, wow, 4 million?
Yeah, it's massive. And because Beth is already authenticated in that ecosystem, the AI doesn't generate a text-based guess.
It actually knows her finances?
Securely, yes. It securely pings the Buyability database, retrieves her unique financial profile, her debt, her credit score, and cross-references it with the specific property's price and live interest rates. Then it generates a factual response.
It literally tells her, given your buyability, this is somewhat within your range, but it's a bit of a stretch.
A bit of a stretch. That is so specific.
Right. Generic AI is like a waiter who can only read you the menu. This specialized AI is like a waiter who is also the head chef and your accountant. Like, it checks the inventory in the fridge and your bank balance before recommending the fish.
That is a perfect analogy. And that API integration fundamentally alters her user behavior. Because the AI provided a hard financial truth, Bella instantly pivots.
She doesn't waste time on a house she can't afford.
Exactly. She adjusts her parameters. She asks the AI to show her homes with 3 bedrooms instead of 4, and she drops her budget cap to $400,000.
And that pivot completely changes her entire market reality. At $450,000 with 4 bedrooms, she only had about 580 homes to look at initially.
Right.
But by dropping the price and the bedrooms based on the AI's financial reality check, she surfaces 1,600 overall options in her actual range.
Options that actually fit her life without making her house poor.
Exactly.
And then she requests live, up-to-the-minute mortgage rates, which the AI pulls directly from the Zillow Home Loans API.
Just seamlessly pulling from another system.
Yep. Then, within that exact same continuous session, she decides she wants to tour one of the properties. The AI executes yet another external function. It calls the Showing Time Plus scheduling tool and books a live confirmed tour for Wednesday at 1:00 p.m.
Unbelievable. So we've seen how an AI can instantly connect these totally disparate databases to move a buyer from just casually browsing to a scheduled tour.
In one session.
Yeah, that covers speed and breadth. But speed isn't enough if the AI can't defend its own math. Which brings up the question, what happens when a user wants to aggressively interrogate a single data point?
And that leads us to the presentation's second conceptual shift, which is depth and self-correction.
Right, and this is demonstrated by our second user, a guy named Peter.
Yeah, so Peter's focused on a specific condo in Seattle, and he begins his session by asking the AI for the home's estimated market value. He is essentially inquiring about its estimate.
Wait, that completely changes the dynamic, because his estimate has historically been a static integer on a screen. It's a black box.
Absolutely.
You look at it, and you either accept it, or you assume the algorithm is wrong. How do you interrogate a static number?
What's fascinating here is that you expose the underlying weights of the algorithm through the conversational interface. The AI mode basically turns the Zestimate into a debate partner.
A debate partner.
Yeah, the AI can explain the specific variables driving that valuation. So Peter asks, does this condo include a pool or a clubhouse?
Which the presenter notes is a really rare amenity in Seattle, meaning its algorithmic weight in the valuation is incredibly high.
Correct. So the AI confirms the pool, and Peter ends up spending weeks diving into the financial minutia of this single property.
Weeks? Wow.
By week 3, he is fully interrogating the ledger. He asks about the HOA fees, and the AI retrieves the data. It tells him it's roughly $275 a month.
Okay, pretty standard.
But then Peter asks if utilities are included in that fee.
And the AI checks the listing data and says, no, utilities are separate.
Right. But Peter pushes back. He says to the AI, actually, I'm pretty sure utilities are included in the HOA dues. The current tenant mentioned that to me.
Oh, wow. This exposes a major vulnerability in literally any real estate platform, which is stale or inaccurate listing data.
It's a huge problem.
And the AI's response here is brilliant. It doesn't just, apologize and log the correction for Peter's private session. It actually initiates a real-time, self-correcting data loop.
Right, it takes action.
Yeah, it flags the discrepancy and alerts the seller's agent, essentially saying, hey, a potential buyer pointed out your online listing is inaccurate regarding utilities. You need to fix this.
It's amazing. By turning the user into an auditor, the AI creates this decentralized verification network. The AI isn't just guiding Peter. Peter is acting as a human in the loop, cleaning up the platform's marketplace data for every other user.
That is so smart.
And once Peter is finally satisfied with the financial integrity of the property, he shifts from the micro to the macro. He stops auditing the ledger and asks the AI to act as a hyper-local concierge.
He starts querying lifestyle parameters. He asks, are there highly rated restaurants nearby?
And the AI maps out Canales, which is a famous fine dining spot, all the way down to Pike Place Chowder.
He queries grocery infrastructure, and it surfaces Safeway and Whole Foods. He asks about points of interest, and it maps out Gasworks Park and the University of Washington, UW.
The system proves it can handle the macro neighborhood data and the micro financial data simultaneously. It understands that Peter isn't just purchasing a structural asset.
Right.
He is purchasing access to a specific Seattle lifestyle.
So we have Beth leveraging the API integrations for broad financial realities. And we have Peter driving deep into data verification and self-correction.
Breadth and depth.
Exactly. But raw data and financial math are really only half the equation when you're moving. The other half is entirely subjective.
Deeply subjective.
Which brings us to the presentation's third conceptual leap. Emotional reasoning and trade-offs, demonstrated by a user named Cindy in the Florida Panhandle.
Cindy really pushes the boundary of what we expect a language model to process. So she finds a home with a beautiful covered pool, but it's located near a busy street.
Tough choice.
Right. And she asks the AI, how big of a trade-off is that? She is literally asking the machine to weigh an amenity against a nuisance.
Here's where it gets really interesting. Because the AI responds by analyzing the valuation impact, right? It notes that the pool adds significant value, and the street traffic didn't demonstrably decrease this estimate. But then Cindy escalates the subjectivity.
She goes even deeper.
Yeah, she looks at a different, highly upgraded house and types, am I stretching for features?
That is such a fascinating query to direct at an algorithm. I mean, am I stretching for features? That is a question you typically ask your spouse.
Yeah.
Or a broker who has understood your risk tolerance for a decade. It requires entirely subjective judgment.
Right, and she follows it up by asking, if I stay 5 to 7 years, does paying more here make sense? She's treating this text interface like a real estate therapist.
And because the system has amassed so much behavioral context, what Cindy has clicked, what she's saved, what she's prioritized across all her sessions, it actually attempts to answer her.
It doesn't just dodge the question.
No, it generates a highly personalized comparison table between two properties. And the presenter joked that anyone could code a basic comparison table in a Python CS 101 class.
Which is easy to do with raw numbers, sure.
Yep.
But weighing the subjective value of a one-car garage, again, something vague like move-in readiness, that requires the AI to weight emotional parameters, not just integer values.
Exactly. It points out that one house, Wintergreen, offers more space and a superior layout, while the other house, Galliano, has the specific garage setup she wants and requires zero renovation.
And then the AI forces a resolution.
This is my favorite part.
It's wild. It presents Cindy with a literal fork in the road. It stops just aggregating data and essentially says, you can't have it all. Option A gets you garage. It's gated and it's slightly newer. Option B gets you an extra bedroom, brand new appliances, and a lower total cost. You have to tell me what your priority is so I can guide your next step.
The AI is acting as a mirror. It is reflecting her own conflicting desires right back at her. It demands that she clarify her core values. It fully evolves from a passive search engine into an active participant in her psychological decision-making process.
But there's a technical hurdle here that we haven't addressed yet.
Okay, what's that?
Right before this big comparison, Cindy asks a highly specific physical question. She asks the AI, does the kitchen get natural light? I have to stop here, because how does a text-based LLM know the photonic reality of a room in Florida?
It's a great question.
It can't just read the word sunny in a listing description and verify that as truth, right?
No, it can't. And that query highlights the shift from standard LLMs to multimodal AI and computer vision. A text model alone absolutely cannot answer a question about natural light. But over the last decade, this platform has built a massive visual database of 3D tours and high-resolution imagery.
Okay, so it's utilizing visual recognition algorithms to tag geometric features in the photos.
Precisely. The computer vision models parse the 2D pixels into 3D semantic understanding.
Uh-huh.
It recognizes a cluster of pixels as a window. Then it identifies its vector alignment as south-facing and maps the open sight lines from those windows directly over the kitchen sink.
That is incredible.
It translates those spatial tags into text vectors that the LLM can pull from. Therefore, the AI can authoritatively conclude, based on actual geometric data, that the kitchen gets excellent natural light.
But leaning on AI for visual data introduces another massive vulnerability, doesn't it? When we talk about AI manipulating images, especially in real estate, doesn't that just invite disaster?
Oh, absolutely.
I mean, we've all seen generative AI create architectural impossibilities. If we are relying on virtual staging, isn't that a prime candidate for one of those trust-busting moments we talked about?
You've identified a critical bottleneck. If you use a generic generative AI to virtually stage an empty room, adding a digital couch and a rug to help a buyer conceptualize the space,
Right.
it averages about 60 to 70% accuracy regarding spatial constraints.
Which means the generative model might accidentally erase a load-bearing wall or render a window right over where a closet is supposed to be.
Exactly.
If a buyer shows up for a tour and realizes the AI deleted a wall in the photos just to make the room look bigger, platform trust drops to zero immediately.
Yes. So the underlying models used in this specific ecosystem have to be strictly constrained by 100% accuracy. They have to honor the definitive physical geometry of the room without any hallucination.
And that absolute requirement for perfect geometric data leads to the final technological reveal in the presentation, a tool called Instant Floor Plan.
Right. And floor plans are basically the most critical piece of visual data for a buyer because the layout dictates the functional utility of the entire space.
The presenter actually shared an anecdote about moving into a house and realizing his master bedroom shared a wall with his kid's playroom.
Oh, no. That is rough.
Right. It's a structural nightmare that you might not even notice on a quick 20-minute walkthrough,
Yeah.
but it totally dictates your daily reality.
Historically, acquiring that accurate layout data was a heavily specialized task. A real estate photographer had to utilize a specialized 360-degree camera.
Oh, yeah, those big tripod things.
Yeah. They had to place it precisely in the center of a room, perform a tedious process of photogrammetry, physically hide in the hallway to stay out of the shot, move the tripod room by room, and then wait hours for the print cloud generation to process in the cloud.
Sounds exhausting. But with Instant Floor Plan, the presentation demonstrates a massive technological leap. They show a video of a photographer in a Portland listing holding a standard iPhone Pro.
Just a phone.
Just a phone. They simply walk into the room and pan the phone around. The phone's built-in LiDAR and spatial mapping software identify the physical corners of the room in real time, building the 3D model directly on the screen as they walk.
And the interface provides immediate verification. If the user pans too quickly and the LiDAR misses a corner, the app alerts them instantly, while they are still physically standing in the room, to rescan that specific spatial coordinate.
We are talking about turning literally any civilian with a modern smartphone into a LiDAR-equipped spatial mapper. It is crowdsourcing the architectural geometry of an entire city in real time.
It really is. And when you synthesize all these technological advancements, the API integration, the self-correcting data loops, the multimodal vision, and the spatial mapping, the presentation describes the result as a stunning wheel of modern real estate.
Meaning the output of one system becomes the high-quality training data for the next.
Exactly. The crowdsourced 100% accurate spatial data and rich media drive deep behavioral engagement. Buyers like Beth, Peter, and Cindy spend exponentially more time exploring the digitized properties.
And because they are leaving a denser trail of behavioral data, the AI has a richer context window to provide that highly personalized emotional guidance, like forcing Cindy to choose between the gated community or the extra bedroom.
Which ultimately allows the system to connect the buyer to the right human real estate agent at the exact moment they are psychologically and financially prepared to execute an offer. It eliminates the friction of premature exploratory tours.
To prove this architecture is driving actual user reliance, the presentation concluded with some staggering engagement metrics. And keep in mind, this was tracked over a very short initial period of access to this AI mode.
The numbers are crazy.
Beth, our first-time buyer in Phoenix, who started just by testing the system's knowledge of slate roofs, ended up having 116 unique conversations across 8 different properties. Peter, the user who audited the Zestimate and the HOA ledger, had 45 highly technical conversations diving into the micro details of just 4 Seattle condos.
He essentially used the AI to run a forensic accounting audit on his prospective investments.
He really did. And Cindy, our user navigating the emotional trade-offs in Florida, she utilized the AI for 14 out of the 14 days it was available to her. She engaged in 176 conversations and prompted the system to generate 43 different personalized comparison tables.
Those metrics demonstrate an unprecedented level of reliance. Users are not treating this as a search bar. They are treating it as a trusted, contextualized confidant.
So what does this all mean? We started this deep dive talking about the visceral panic of moving, the cardboard boxes, the sheer exhaustion, the
Mhm.
feeling of being totally overwhelmed by the biggest financial and emotional decision of your life.
All right.
What we are seeing in this presentation is the evolution of moving from a blind, stressful scramble into a highly curated, structurally verified conversation. You aren't just shouting parameters into the void of a generic search engine anymore. You're negotiating your future with an integrated system that can ping your bank account, parse the geometric vectors of natural light in a kitchen, and demand that you clarify your own conflicting values.
It is replacing the profound anxiety of the unknown with radical, mathematically and visually verified clarity.
And that leaves us with one final thought for you to mull over. If a multimodal AI can successfully guide us through the complex financial, spatial, and deeply emotional trade-offs of buying a home, if it can learn what we value more than we might even realize ourselves, what other monumental, highly personal life choices will we soon find ourselves securely outsourcing to an algorithm?